Let us resume. We have seen the running fix with wind. Now let us see running fix with current also.
Let's take up the questions. Same problem, only thing is this time no wind, but experiencing current. A vessel steering 070 degrees true at 12 knots.
Is the video audio okay, beta?
Yes, sir, it's okay.
Okay, all right.
Observes Roche's point light bearing 010 degrees true at 2000 hours. At 2130 hours, it observes Cotton Island light bearing 320 degrees true, same as earlier cases. If during this period it experienced current setting 180 degrees true at 2 knots but no wind, find the vessel's position, CMG and SMG. Now, as already explained during the allowing of wind and current, we have to ask ourselves the question, are we going to counteract current or allow for current?
Can you tell me, beta, in this particular question, will it be counteracting or will it be allowing?
Allowing. We will allow.
Very good, beta. It will be allowing for the current because you see they have given us the course steered, which is 070 and the engine speed, and they have given us the current, so we will have to allow for the current.
In this case, we have CTS, CMG is to be found, so it shall be allowing for current. There's no wind, so the two displacement vectors are one because of ship's own propulsion and the other is because of the current. So let's get going with the question. We'll identify the landmarks. We draw the 2000 RPL. We draw 2130 PL. We take any point on first PL. Now we draw the CTS through it, indicated by single arrow, mark off engine distance for 1.5 hours, that is point B. So this is 070 degrees true into 18 miles. Now we have to allow for current. I hope you remember when you allow for current, the current is applied at the DR position or the arrow head end of the CTS line. That means now the current has to be allowed at point B. So we allow the current here, represented by 3 arrows. The rate of the current is 2 knots. So in 1.5 hours, the drift would be 3 miles. So we mark off from B 3 miles on the current sector vector and we get point C. B to C is 180 degrees true and 3 miles off. So A to C now gives us the CMG and A to C gives us the DMG in 1.5 hours. So if the vessel was at point A at 2000 hours, then because of her own propulsion and the current, in 1.5 hours, that is 2130, the vessel would have reached point C. That means point A stands transferred to point C. So this time the PL shall be transferred through point C. So we transfer the PL through point C, indicated by 2 arrows at each end, time indicated against it, and where it cuts the 2130 PL, that becomes point X, the 2130 fix. Again, like the previous questions, she would have moved along her CMG track in reaching this position. So we transfer the CMG through 2130 position, where it cuts the 2000 PL, that becomes point Y and 2000 fix. So in this question now, point Y is fixed at 2000 hours, point X is fixed at 2130 hours, Y to X is the CMG, and Y to X is the distance made within 1.5 hours, when divided by time of 1.5 hours shall give us the speed made good.
Okay, so this plot is complete now, beta. Just have a good look at it and let me know if you have any doubts. All clear, beta? Everything clear?
Yes, sir.
Very good. So that was an important concept, running fix with the current. Let's proceed ahead then.
So now you see what we have learned in the previous videos. If we are thorough with that, these questions will automatically start falling in place. Now let's take the last example in which we have both wind and current.
Okay, so now we come to the last question of this particular concept, and here we are involving all the forces. So we have the wind also and we have the current also. Now one important point to keep in mind when both of these are present is what is the order in which you allow for them. So do you remember, beta? We
Sir,
had
if
discussed it during
First for leave it, then for
yes, sir. If we are allowing
Very-
then wind and current, if counteracting then current and wind.
very good, beta. So you remember it. We discussed it in the current and wind video also. So when you are allowing for it, we first allow for the wind and then allow for the current. And when we are counteracting, we first counteract the current and then counteract the wind. So let us see it practically now in this question. Now the basic question, base question remains the same. Only thing is we have the current as well as the wind both acting in the area now. So we will be plotting using both of them.
Same vessel steering 070 degrees true at 12 knots, observes Roche's point light bearing 010 degrees true at 2000 hours, 2130 bore, 320 degrees true. During this period, the current was setting south as in the earlier case at 2 knots and northwesterly wind causing 3 degrees leeway. Find vessel's position at 2000 hours and 2130, CMG and SMG. Before I start plotting, I ask myself few questions. In this case, we have the vessel's propulsion, we have the current, and we have the wind. First, we ask ourselves a question, do we have to allow for wind and current or do we have to counter it? Obviously, your answer would be allowing. Why? Because CTS is known, CMG is to be found. If they have to be allowed, in which order to allow? Please remember your earlier knowledge. You have to first allow for wind and then allow for current. Wind, as explained earlier, can be allowed for on answer sheet. So as seen when we had the wind problem earlier, when we had the wind problem, we got an effective track of 073 degrees true. So in this case also, when you are allowed northwesterly wind, the leeway track shall automatically be 073 degrees true. So we get going with the plotting, identify the landmarks, draw the PL at 2000 hour, draw the PL at 2130 hours. Take any point on the first PL, that is A. Now what do we draw through A? Is the effective course of 073. How many arrows do we represent it with? Single arrow. What will be the magnitude of this vector? Tangent distance for 1.5 hours, 18 miles. Cut that off and we get point B. Now because it is 073, so wind is already allowed for. Now we allow for current for 1.5 hours, so we draw the current at D, represented by 3 arrows. Drift in 1.5 hours at 2 knots will be 3 miles. We get point C, 180 degrees into 3 miles from D. Now A to C becomes the course made good, and point A is transferred to point C. Why? Because if the vessel was at point A, steering 070 degrees true at 12 knots, experiencing wind and current as given in the question, then she would have done this effective course, and this current would have brought her to C. So point A gets transferred to C. So now we transfer the first PL through point C, mark with 2 arrows, indicate the time, and we get the position at 20, 130. Draw the CMG through this position where it will cut the first PL, that becomes the position at 2000 hours.
Okay, so this plot is also complete beta. We have first allowed for the wind, got our leeway track or effective course, plotted the leeway track, then allowed for the current and got our course made good and distance made good, which we used for transferring the position line. So have a good look at the plot and let me know if there are any doubts.
No, sir.
Okay, very good. All clear beta? This topic was also there in second mates, so I hope you remember what was done. Everything is refreshed now.
Yes.
Okay, great, very good. So with this, basically we complete the running fix using a position line.
सर एक बात पूछनी थी
बोलो बेटा.
सर जब आपने बोला एक लाइट हाउस से दो बेयरिंग दी हो तो वो सर सेम क्वेश्चन एक 2 पॉइंट बेयरिंग का भी बन जाता है ना सर.
बेटा इसी का दूसरा नाम जो है उसको 2 पॉइंट बियरिंग बोल देते हैं. So that's a slang term which we use. That 2 point bearing is solved with a running fix concept only.
ओके मतलब दोनों सेम बात है सर.
Right beta, both are same.
ओके सर.
Okay. Later on when we move on, so this 3 point bearing topic will also come, but that will come once we have done the running fix concept. After that we will have the 3 point bearing, so don't bother about it right now. So what we have done now is the running fix concept using a position line. The next thing which we have going further is the running fix with a position circle. So as we have transferred a position line, the same way we will be doing the transfer of a position circle. A position circle is transferred by transferring its center. जैसे हमने अभी PL में देखा, we took any hypothetical point on the PL. जो A point हमने अपने plot में लिया था, that could be any hypothetical point on our position line. Now when we are transferring a position circle, we do not have the choice of picking up any point on the circle. For transferring a position circle, we have to transfer its center. So the same effective course and current, wind and current which was applied to a hypothetical point A on the position line, in case of a circle, it will be applied at its center. So then we get a transferred center, and when the transferred center is obtained, we make the transferred position circle having the same radius as the original position circle. So shall we move on to this concept now, running fix with a position circle? Okay, so beta, moving on to the transfer of a position circle. So the concepts which we will be using are the ones which we have already covered, that is position lines, position circle, allowing for wind and current, the running fix, transferring position lines. These have already been covered up. So let's move on to transferring a position circle now.
Now, the minimum information that was learned by us required to draw a unique circle on a plane surface, and in our context, a unique position circle, is that we need to know or obtain its center and radius.
Beta, is the picture and the audio coming clear?
Yes.
Yes.
Okay, all right.
So we need to carry out an exercise which gets us the center and the radius. Thus, transfer a circle, we must only transfer its center. Unlike the transfer of position lines, where we could have taken any point of our choice in the PL and run it up. In case of position circle, we do not have a choice. I repeat, we have to transfer its center and only center. That is, run up its center for the duration required. The transferred PC is then drawn through the transferred center and same radius as the radius of the circle being transferred. Method of transferring the center is the same as what we learned in the method for transferring any point on the PL. Time to which PC is transferred may be indicated against the transferred PC plotted on the chart.
Okay, so all clear up to here, beta? Any doubt in the mind? Okay, very good.
Now, how do we transfer the position circle? Let's list down the steps. First, we need to identify the center of the position circle. The center of the position circle will depend upon the method that has been used or deployed for obtaining the position circle. Imagine the vessel to be at that point as the center of the circle. The duration of transfer allow the following as applicable to this particular position, that is the center. Ship's propulsion displacement comprising of the course she steered and the engine distance she covered during the interval. Wind allowed for through its leaving and vent allowed through its set and drift. The position thus obtained is the transferred center. Now, with this transferred center as the center of the circle and same radius as the radius of the PC to be transferred, we draw the transferred position circle.
So you can see here, beta, the procedure is exactly the same as we followed with a PL, with the only difference. On a PL, the point A was any hypothetical arbitrary point of our choice. But in case of a position circle, the point always has to be the center of the position circle. So all these three forces which are acting on the ship, one is the ship's engine, second is the wind, third is the current, they are applied on the center of the circle and we obtain the transferred center, and this transferred center is used to draw the transferred position circle.
Now, let us quickly review the identification of a center, because as I said earlier a while back, that the center of the position circle shall depend on the method which has been deployed to obtain the position circle. Now, if we have got a position circle by radar range, then the object whose range has been measured by radar acts as the center. And obviously the range is the radius. In case we have used the concept of horizontal angles, then the point of intersection of the angle arms drawn at the baseline becomes the center of the circle, and the distance from the center so obtained to either end of the baseline gives you the radius of the circle. Vertical angle, object whose vertical angle has been measured is the center, and the range calculated by vertical angle formula that we learned under the position circles is the range. Raising, dipping, first sighting, last sighting the lights, the center is the light being sighted, and the sighting range, which is lesser of the geographical range and the present luminous range, constitutes the radius. High altitude celestial observations, in case they are applicable to your grade, the GP or the geographical position of the celestial body acts as the center, and the true zenith distance expressed in minutes is the radius of the position circle.
Okay, so this is a refresher of the position circles which we did. So these were all the methods which we used, and for every method the center and the radius which we got. So any doubt up to here, beta?
सर ये वर्डिंग्स वैसे समझ नहीं आई, जैसे पहले वाले में रडार रेंज पॉइंट हुज रेंज इज यूज्ड रेंज
ओ
थोड़ी मतलब
ओके
पेपर चार्ट में देखेंगे तो समझ आ जाएगा, बट वो पॉइंट टू पॉइंट नहीं सर समझ आया।
राइट बेटा, अभी समझा देता हूँ। देखो ये जो फर्स्ट लिखा हुआ है रडार रेंज, दिस इज द मेथड विच वी यूज्ड फॉर ऑब्टेनिंग ए पोजीशन सर्कल। सो हमने एक ऑब्जेक्ट की, एक लाइट हाउस की रडार रेंज ऑब्टेन की फ्रॉम द रडार, ऑब्वियसली हमारे पास आ गई। अब जब हमें इसे चार्ट पे बनाना है तो हमें कोई भी सर्कल अगर बनाना हो तो उसका सेंटर पता होना चाहिए और उसका रेडियस पता होना चाहिए। इस मेथड से अगर आपने रडार रेंज निकाली है तो सेंटर होगा जो भी पॉइंट आपने रेंज के लिए यूज किया था, लाइट हाउस, बीकन, that will be the center, and radius will be the range which you obtained from the radar.
Yes sir.
Okay beta, you can check it with other methods also. The first column gives you the name of the method. Second column tells you how to identify the center, and the third column tells you how to find out the radius. Okay, once you know the center and the radius, it is very easy for us to make the circle on the chart.
तो जैसे सर ये रेजिंग डिपिंग वाला क्वेश्चन है,
राइट
सर इसमें हमें जैसे लिखा देता है कि वो इतने बजे दिखा,
राइट
सर उसमें पीएल लगी होती है, मतलब ना अपने उसमें ये सेक्टर बना होता है, उस पे लाइट हाउस पे लाइनें लगी हुई हैं, लेट्स से डॉटेड वाली सर दोनों साइड पे, कि लाइक ये दिखने वाली और ये सेटिंग होने वाली, राइजिंग वाली और लास्ट वाली। तो सर उसमें हमें
आप थोड़ा सा कंफ्यूज कर रहे हो। जो रेजिंग डिपिंग वाला कॉन्सेप्ट है
नहीं वो गलत है सर, फर्स्ट साइटेड और लास्ट साइटेड की बात करो। हाँ जी, फर्स्ट साइटेड और लास्ट साइटेड की बात कर रहा हूँ सर, जैसे लाइट हाउस के छोटी डॉट।
ओके अब देखो बेटा, लेट मी एक्सप्लेन इट टू यू। जो फर्स्ट साइटिंग और लास्ट साइटिंग है ये दो तरीके से होती है। वन इज बिकॉज ऑफ द रेंज, when you are going close to a light at a certain point it will be first sighted, and when you are moving away from a light at a certain point it will be last sighted. एक तो वो सिनेरियो है जिसमें आप किसी लाइट हाउस को फर्स्ट और लास्ट साइट कर सकते हो। दूसरा भी एक सिनेरियो है, वो ये that if you have a sector light, correct, it is visible only in a particular sector, right, and in the other sector it is obscured by a hilltop or anything else. Now in that case, when the light will first appear is not dependent upon the range, it is when you enter into that sector. So ये दोनों पॉइंट अलग अलग हैं बेटा। आप कौन से पॉइंट की बात कर रहे हो, रेंज वाला या सेक्टर वाला?
सर मैं सेक्टर वाले की नहीं, मैं रेंज वाले की बात कर रहा था।
ठीक है बेटा, आप बताओ डाउट इसमें क्या है?
तो चार्ट पे देखूंगा तो थोड़ा हो जाएगा अपने आप ही क्लियर, सब कोई इशू नहीं इसमें, तो जस्ट बताने में नहीं हो रहा।
Okay, no problem. Whenever you have a doubt, when it is clear in your mind what is the doubt, just let me.
जी सर, चार्ट पे
Okay,
देख के हो जाएगा, ठीक है सर।
right beta, right. So any other doubt beta? Okay, very good. So let's proceed ahead then.
Now with this background to transferring of position circle, let us consider some examples in which we learn how to transfer the position circle. At 2000 hours, a vessel steering 250 degrees true at 12 knots observes Ballina Cotton Island light 5 miles off by radar. At 20:45, Roche's point light bore 000 degrees true. If there was no wind or current, find the position at 2000 hours, position at 20:45, CMG and SMG. So no wind, no current, that means CTS and CMG are the same. Distance made good and engine distance will be same. So
okay, so this question is clear, beta. Any doubt in the question?
No, sir.
Very good. So you see, at 2000 hours, they have given us a radar range of 5 miles. So we have a position circle for this particular time. Then at 20:45, they have given us a bearing. So Roche's point light bearing is given. So we have a PL. So we will be transferring the position circle now using the running fix concept and finding our positions at both these times.
first we identify the landmarks. Here is the Ballycotton Island light. This one is the Roche's point light.
There's a small correction. The name mentioned here is Ballina Cotton. It is actually Ballycotton. Ballycotton, huh?
The Ballycotton Island is center and radius of 5 miles. That's the radar range. We draw the circle with C1 as the center, and this is the circle for 2000 hours. We have another position line at 20:45. That means we have two observations. First one being a position circle, second one being a position line. They are staggered observations. So what we decide is we run up this 2000 hour position circle to 20:45. So we draw.
Okay, so we have just plotted our initial position circle, and now we are going to transfer this position circle to 20:45 because our second PL is at 20:45. So as discussed earlier, we apply all the vectors, the CTS vector, the current vector, the wind, everything what is there to the center of the circle. So in this case, this is a simple question. There is no wind, no current. So we just have the engine CTS vector to be applied. So we are applying that on the center of the circle now.
Apply the CTS at the center. Why? Because we've just learned that to transfer a position circle, you need to transfer its center. CTS is represented by one arrow. In 45 minutes at 12 knots, the engine distance shall be 9 miles. So this is 250 degrees true into 9 miles. We get this point C2 out here. Now, in this case, as there is no wind and no current, obviously this CTS is also the CMG. So we represent it by two arrows on this out here. Now, obviously in this case, the distance made good would also be the same as the engine distance, and therefore point C1 is transferred to point C2. So that means the center of 2000 position circle is transferred to C2. With C2 as center and radius of 5 miles, that was the same as the radius of 2000 hour circle, we draw the transferred position circle. The green circle which has now come up on the chart is the transferred position circle. That means at 20:45 the vessel would be somewhere on the green circle.
So all clear up to here, beta? Position circle is transferred now. Any doubt?
No, sir.
Very good.
At 20:45, the question also gives us a position line where Roche's point light is bearing 000 degrees true. So we plot the 20:45 PL. We have a 20:45 PL and a 20:45 position circle where the two intersect, that is point Y, becomes the position at 20:45. Obviously, in reaching position Y, vessel would have made good a course which is represented by C1, C2. So the CMG C1, C2 is transferred through Y and magnitude also is equal to C1, equal to the magnitude of C1, C2. Now where this cuts 20-100 hour circle, that is at point X, that becomes the fix at 20-100 hours. Needless to say, point X is the 20-100 hour fix, point Y is 2045 fix, X to Y is the CMG, and magnitude of X between X to Y, or distance between X and Y, is the distance made good in 45 minutes, from wherein we can convert it to distance made good in 1 hour, thus getting the speed made good.
So all the things which they had asked us, they have been solved in the plot now. This question is complete. So any doubts in the mind, beta? Very good. So that means all clear. Great. Let's proceed ahead then.
So one question, sir.
Bolo beta.
Sir, if we extend that XY line like 20 circle, it will meet somewhere to the outer limit. So we can somewhere there also. No? How will show we are there at X?
You mean to say that if we extend the YX line further, it will meet the circle at this place, right?
Right, sir.
Okay. अब देखो बेटा, ये जो C1, C2 हमने निकाला है, this is our CTS vector and also our course made good, distance made good vector, because there is no wind and current, right?
Right, sir.
Right. So that means in 45 minutes, 2000 to 2045, you can cover only this much distance, that is C1, C2.
Yeah, so that I understood. I mean that you see you have put a to this CMG arrow at point XY. So it also cut here, na? So it will take this point and that point, it will also same. You understand this point, and if we extend the X line, so it will meet somewhere at 20 and circle somewhere here, yeah, right?
Right. But that cannot be our position, beta, because in 45 minutes, the vessel has moved only this much distance and 2045 position is fixed. You cannot be at any other place at 2045. You cannot be here at 2045, because then the bearing of Roche's point will not be 0, 0, 0 then.
Okay, sir. Understood.
Okay. So that is why you cannot extend it backwards up to here.
I mean, they will give us something so we can, by the speed, we can understand we are here.
Right, exactly. See, in most of the question, 90% of the questions, you will have your final position fixed up. So whichever part of the circle your final position is, when you go back, on the same part, you will have the initial position also. Okay?
Understood, sir. Understood.
Oh.
Understood. If we don't have that, the final, then we have some doubt. But if final is given, then we don't have any doubt. So we can, we can understand this will.
Yes. You will always have a final fix, beta.
Okay, sir. Thank you, sir.
Okay. Let's proceed ahead.
Sir, one more doubt, sir.
बोलो बेटा.
सर ये जो डिस्टेंस आया सर, ये 45 मिनट्स के लिए होगा या फिर ये 1 आवर के लिए कन्वर्ट करना पड़ेगा ना, स्पीड मेड गुड के लिए?
Very good, beta. Right side, see where my cursor is. What is the speed of the ship?
Sir, 12 knots.
Very good. And we are transferring it for how much time?
Sir, 45 minutes.
So with a speed of 12 knots in 45 minutes, how much distance will you cover?
Sir, 9 miles.
See this distance here, 9 miles.
Yes, sir.
So this C1, C2 is the distance made good, or the engine distance, both are same in this question. So this is for 45 minutes, beta.
Yes, sir. Sir, तो लेकिन क्वेश्चन में पूछा स्पीड मेड गुड, तो that will be for.
Okay. So yes, you are right. The distance made good is 9 miles, that is required for transferring the position circle, but the speed made good we will have to convert it to 1 hour, so it will come as 12 knots only. The speed made good will be 12 knots.
ओके सर, ओके, थैंक यू।
ओके, सो और बताओ बेटा, और कोई डाउट?
तो सीएमजी तो उन्होंने दिया ना, वैसे नो स्पीड तो दिया ना 12 नॉट, तो सीएमजी तभी होगा अगर हमारे पास करंट होगा, तभी कुछ इफेक्ट होगा स्पीड पे, अदरवाइज इट विल रिमेन सेम।
राइट बेटा, राइट। इन दिस क्वेश्चन इट रिमेन्स द सेम। जो अभी नेक्स्ट क्वेश्चन हम करेंगे व्हेन विंड एंड करंट गेट्स इन्वॉल्व्ड, उस केस में ये डिफरेंट हो जाएगा। वी विल सी जस्ट नाउ।
सर एक
कंफ्यूज करने के लिए दिया होगा।
सर एक
हाँ बोलो
जस्ट फॉर नॉलेज हम इसको रिवर्स भी कर सकते हैं सर, रिवर्स ऑर्डर में।
means you want to say if I wanted to transfer it from 2045 to 2000.
करेक्ट सर, उसमें पीएल ट्रांसफर हो जाएगी।
राइट बेटा, राइट, इट कैन बी डन, यू आर राइट, इट कैन बी डन, मैथमेटिकली पॉसिबल, बट चार्ट वर्क में मोस्ट ऑफ द टाइम हम अहेड रन ही अप्लाई करते हैं, रिवर्स रन अप्लाई नहीं करते हैं।
बट सर अगर पॉसिबल है तो अगर ये सर्कल बड़ा होगा और पीएल का हम आर्बिट्रेटरी पॉइंट नीचे लेंगे काफी डाउन में, तो 2 पोजीशन सर्कल पे कट जाएगा ना एंड में। तो सर
ओके बेटा, पहले तो जो अभी डाउट आपका था कि हम इसे रिवर्स में कर सकते हैं क्या, आई सेड यस वी कैन डू इट, बट वी एज फार एज मैथमेटिक्स इज कंसर्न्ड यस, ज्योमेट्री इज कंसर्न्ड यस, इट कैन बी डन, बट एज फार एज चार्ट वर्क इज कंसर्न्ड हम रिवर्स रन प्रेफर नहीं करते हैं। उसका रीजन ये है दैट एज ए नेविगेटर वी आर ऑलवेज इंटरेस्टेड इन आवर लेटेस्ट पोजीशन, सो वी अवॉइड going reverse and we always prefer going ahead. So is that sorted out beta? Clear?
yes sir, but अगर मैथमेटिकली कर सकते हैं, अगर हम पोजीशन सर्कल एक बड़ा अज्यूम करते हैं, लेट्स से 10 to 20 नॉटिकल माइल, और फर्स्ट हम जो पीएल पे कोई आर्बिट्रेटरी पॉइंट अज्यूम करते हैं, हमने काफी नीचे अज्यूम किया, कहाँ से उससे बैक रन लगा दिया, जो हम कोर्स स्टीयर कर रहे हैं उसे ऑपोजिट लगा दिया, फिर उस पीएल को एक पॉइंट पे ट्रांसफर कर दिया, वो कहीं सेकंड सर्कल पे काटेगी, जहां भी काटेगी फिर सर्कल ट्रांसफर करेंगे, वो 2 पॉइंट्स पे नहीं काटेगा सर पीएल के।
Okay, you mean to say if I transfer this PL backwards, it will cut the blue color circle at 2 places, right?
No, इसमें तो सर एक तो लैंड हो जाएगा, ये तो सॉर्ट आउट हो जाएगा, इसमें तो क्लियर हो जाएगा।
मान लो इधर नेविगेबल वाटर होता तो ये C1 island होता and we had navigable water all around, that is what your doubt is?
नहीं सर, मेरा नेक्स्ट डाउट है, हमें 2000 की फिक्स मिलती, उसके बाद फर्दर हम इस पॉइंट से अगर फिर पोजीशन सर्कल ट्रांसफर करते हैं, मैं पूछ रहा हूँ वो आगे फर्दर पीएल पे 2 पॉइंट्स पे इंटरसेक्ट कर सकता था ना सर?
नहीं बेटा, अब अगर आपने पीएल को बैक रन लगाया है, उसके बाद फिर पोजीशन सर्कल को दोबारा ट्रांसफर करने की जरूरत नहीं है आपको। अगर आप पीएल को बैक रन लगाते हो तो 2000 फिक्स मिलेगी।
करेक्ट सर।
उस 2000 फिक्स पे आपने सिर्फ अपना सीएमजी आगे लगाना है और आपको 2045 की पोजीशन मिल जाएगी। यू डोंट नीड टू ट्रांसफर द पोजीशन सर्कल नाउ इफ यू यूज दैट मेथड।
हाँ ठीक है सर, क्लियर।
ओके,
समझ गया सर।
पर फंडामेंटली हम वैसा करते नहीं हैं, वी ऑलवेज प्रेफर ट्रांसफरिंग अहेड।
हाँ सर, वैसे ही पूछ रहा था कि दोनों से आंसर आ सकता है कि नहीं टेक्निकली।
यस, यू विल गेट द आंसर।
सर वो इसलिए सर क्योंकि कभी-कभी जैसे वो 2 पॉइंट बेयरिंग जो हम कह रहे थे, जो बेसिक सेम कॉन्सेप्ट एज रनिंग फिक्स, सर उसमें कभी-कभी पीछे की पोजीशन फाइंड आउट करने के लिए बोला जाता है।
वो तो हमने की है बेटा, जो हमने ट्रांसफर पोजीशन लाइन वाली रनिंग फिक्स की है, उसमें हमने पीछे वाली पोजीशन भी फाइंड की है, पर अहेड रन लगाया था। उस सब में हमने अहेड रन ही लगाया है बेटा, स्टिल वी वर एबल टू फाइंड द प्रीवियस पोजीशन।
नहीं सर, वो उससे नहीं बोल रहा था, सेकंड पीएल ट्रांसफर करने को बोल रहा था कुछ और।
ठीक है सर, छोड़ो।
ओके ओके ओके, सो शैल वी मूव अहेड बेटा?
सर
यस
सर एक डाउट है सर।
हाँ बोलो बेटा बोलो।
जैसे ये जो पोजीशन सर्कल जैसे हमने पहले बनाया तो C1 से लेकर, तो अगर ये सब ऐसे बनता, दूसरी वाली जो हमने ये PL है, जो PL अपनी जो लाइट से आ रही है, अगर इस PL पे ये पोजीशन सर्कल जो हमने ट्रांसफर करा है ये दो जगह काटता, तो हम कौन सा डिसाइड करते हैं कैसे कि हमारा 2045 का फिक्स कौन सा है?
So basically you are saying that let us say if the Roche's point was somewhere here on top and the PL would come like this and we have navigable waters at both locations, which position do we pick as our position? There will be two options, right beta? This is the doubt na?
Yes sir.
Okay. अब इसके लिए बेटा दो चीजें हो सकती हैं. One, they will give you a hint in the question, some hint which will tell you whether you are at the upper location or at the lower location. कोई ना कोई hint question में आपको दिया होगा. Later on some question will come where we will see the hints being given. This could be one option. Second option बेटा, अगर ये दोनों navigable waters में आ जाती तो आप क्या करते? क्वेश्चन में देखा आपने कोई हिंट नहीं. व्हाट यू डू इज, आप इन दोनों ही पोजीशंस पे, एक तो वाई पोजीशन है, दूसरी विल कम हियर, दोनों पे ही अपना CMG रिवर्स डायरेक्शन में लगाओ. यू विल सी दैट वन ऑफ द CMG विल आइदर पास ओवर लैंड और थ्रू नॉन नेविगेबल वाटर्स. सो इमीडिएटली आपको पता चल जाएगा दैट मेरा CMG ये नहीं हो सकता है and it will cross out one of the position. So either
सर इसी क्वेश्चन में हिंट है तो है सर, ऊपर कैसे पोजीशन हो सकती है सर? रोचेस पॉइंट की बेयरिंग 0-0 है, ऊपर वाले से 0-0 बेयरिंग कभी आएगी नहीं सर.
बेटा उसने अपने दिमाग से नया क्वेश्चन बना दिया है. He has made a new question where he has put Roche's point on top and there is no land. उसने नया क्वेश्चन बना दिया है बेटा.
ओके सर.
ओके बेटा समझ गए?
जी सर समझ गया सर.
ओके और कोई डाउट बेटा? वेरी गुड. सो शैल वी प्रोसीड अहेड?
सर ये जो अलाउइंग वाला करंट है उस पे एग्जांपल आएगा ना अभी आगे?
Allowing for wind and current beta?
हाँ सर इसमें ट्रांसफर पोजीशन
we will have beta, we will have. Let's see that.
Now we take the same example, but now we introduce only wind. At 2000 hours, a vessel steering 250 degrees true at 12 knots observes Ballina Cotton Island light 5 miles off by radar. At 20:45 hours, Roche's Point light goes 000 degrees true. If the vessel experienced northwesterly wind causing 3 degrees leeway, but no current, we need to find the two positions, CMG and SMG. First, we allow for wind. It is allowing for wind. Why? Because we know the CTS, we have to get the effective course. So, I'm sure we are all thorough with the wind. Allowing for wind, if you are thorough, then you could skip this step and the allowance could be made in the answer sheet. But let us still have a look at it. This is the CTS of the vessel, 250 degrees true. Wind is northwesterly. Now,
can you tell me beta effective course in this case?
247.
Very good beta, very good.
Leeway shall be allowed to the lee side, that means to the port side. We allow the leeway to the downwind side and we get as the effective course represented by single arrow. What do we see? Effective course or the leeway track is 247 degrees true. In this case, the leeway got subtracted. The same thing you can see in the box now. We could do in the answer sheet through these three simple steps. CTS 250 degrees true. Leeway 3 degrees northwesterly wind. As I said earlier, wind, direction and the CTS have to be considered together to decide whether to add or subtract. So the effective course becomes 247 degrees true. Now instead of drawing the CTS on the chart, we'll now draw the effective course or the leeway track, and the magnitude of this would be same as the engine distance in 45 minutes. So we plotted here now. So we have this as the Ballycotton Island light. We have the Roche's point with C1 as the center and the radius of 5 miles. We draw the position circle for 2000 hours. Now to transfer it to 2045, we need to transfer C1. Since we have already allowed for wind and got the effective course as 247 degrees, we draw 247 through C1 represented by single arrow. On this we mark off engine distance for 45 minutes, that's 9 miles. 247 degrees into 9 miles, we get point C, C2. That means now C1 is transferred to C2 because there is no current in this question. So with C2 as the center and 5 miles as the radius, we draw the transferred position circle. Why? Because C1, C2 also the CMG and C1, C2 is also the distance made good. So we draw the transferred position circle. Green position circle is the position circle. Green position circle is the position circle for 2045. Now we draw the 2045 PL. This is 2045 PL, where the two intersect here. It is the position point Y. It is the position at 2045. Now we transfer C1, C2 both in direction and magnitude through Y, and where it cuts the 2000 hour position circle, this point X is the position of the vessel at 2000 hours. So X is the position at 2000 hours, Y is the position at 2045, X, Y is the course made good, and XY distance is the distance made good in 45 minutes, giving us the speed made good.
Okay, so this plot is also complete now, beta. We had only wind here, so we use the effective course for transfer, and we have the position as well as the CMG vector. So let me know if there are any doubts, beta.
सर एक चीज पूछनी थी, ये जो पोजीशन सर्कल ट्रांसफर वाला है, इसमें वाइस वर्सा भी है या सब में स्केयर कोर्स दिया हुआ है, सीएमजी ही निकालना है, या वाइस वर्सा भी है कि मतलब सीएमजी दे रखा है, क्योंकि सीएमजी को हम सेंटर ले सकते हैं जो भी अपन को सेंटर दिया लाइट हाउस पे वैसे.
You mean to say they have given you the CMG in the question?
Yes sir,
right?
I mean to, yes sir.
Usually beta होता नहीं है, because that will make the question simple. They will not give you CMG directly. They will give you CTS and the current or the wind. So otherwise it will be very very simple.
तो बेसिकली इसमें सिर्फ अलाउिंग वाला करंट का ही क्वेश्चन आता है, काउंटर अट्रैक्टिंग करंट का नहीं होगा पोजीशन सर्कल में.
That's right beta. You will have the allowing question here.
आंसर अगर सीएमजी दिया हुआ हो तो उसको कैसे करेंगे, जैसे वाइस वर्सा लेना हो तो?
Beta, if the CMG is given, then so there is no issue. Apply it to the first center and you get the transferred center. If CMG, if you mean to say CMG is given to you and the initial position circle is given to you and you want to transfer that position circle, right?
We need to find out the CTS and uska engine speed.
No, that will not be there, beta. Yeah, that becomes a question of counteracting. It will not come with this.
Okay.
Okay, वैसा नहीं आएगा बेटा. It will always be allowing.
Position circle में always be allowing. Not like the position lines or other lines.
No, it will be always allowing.
Okay.
Okay. और doubts बताओ बेटा. Any doubts? Okay.
No, sir.
Very good beta. Very good. So we have done without wind and current. We have seen this wind example now. Let us now see the current example. We are finished with the session. You want me to continue or you want to have a break?
Sir, continue.
ठीक है बेटा. ठीक है. Okay. Let's continue.
Now we take one more example wherein there is no wind but only current. At 2000 hours, a vessel steering 250 degrees true at 12 knots observes Bellina Cotton Island light 5 miles of radar. At 2045 hours, cautious light 4000 degrees true. If the current was setting south at 4 knots, but no wind, we have to find the two positions, CMG and SMG. Since the current has to be factored, we ask a question, counteracting or allowing. CTS known, CMG to find, obviously it's allowing. So we basically first draw the first position circle, both landmarks identified, with C1 as center, 5 miles as radius, we get the 2000 hour position circle. Now we have to run up C1 by 45 minutes, and we have to we have the ship's propulsion displacement and current has to be allowed for. So we first draw the CTS of 250 through C1, single arrow, 45 minutes engine distance shall be 9 miles. We cut off that point and we get point A. A would be the DR, not really DR because the ship is not at C1. So, but if the ship was at C1, then she would have reached the DR would be A. Now we allow the current at point A, which is the arrowhead end of the CTS line. So southerly current is allowed here, represented by 3 arrows. Now, if the rate of current is 4 knots, drift in 45 minutes shall be 3 miles. We cut off 3 miles, we get point C2. C1 to C2 is now the course made good, and C1 to C2 is the distance made good in 45 minutes. Now, with C1 as the center, with C2 as the center and radius of 5 miles, we draw the position circle. The green one is the transferred position circle. That means vessel shall be on the green position circle at 2045. Now we draw the 2045 PL to Roche's point, where the two intersect, that is point Y, is the 2045 fix. So this we draw C1, C2 through 2045 position, and where it cuts the 2000 hour position circle becomes position to point X, and that is position at 2000 hours.
Okay, so we have completed the transfer of the position circle in case of current. So you can see the entire plot now. So just have a good look at it and let me know your doubts better. Let us say हमारा ये जो circle है, it was. I hope you can see the screen now.
हाँ sir, screen दिख रही है.
Okay. So you were saying that if this circle was something like this.
That's correct, sir.
Now there are two options of our fix at 2045. One is this, other one is this.
Yes,
right?
sir.
So let's name them. Let's name this as P and let's name this as Q. Okay. अब बेटा अगर ऐसा कोई ऑप्शन आपके पास आ जाए, what you have to do is we have the C1, C2, the CMG vector. It is known to us now. You apply this C1, C2 vector to both these positions. So Q पे जब apply करेंगे, it will go like this up to here, and when you apply it to P, it will go like this up to here. Correct, beta?
Correct, sir.
Now, out of these two, which can be our CMG? Going backwards from P or going backwards from Q?
Sir, that's absolutely correct. In this chart, if I agree, क्योंकि वो land पे चला गया तो possible ही नहीं है.
Right. But just hold on, we will go further. So यहाँ पे हमें clarity मिल गई है. Even though the final positions were both in navigable waters, but when you go back, you see the CMG running over land and your initial position also coming on land, which is not possible. So it immediately tells us this one is not possible and this one is the correct one. So पहला doubt sort out हो गया है. अब चलते हैं further. Now tell me the second doubt.
सेकंड इज लाइक दिस सर, ये तो ऊपर नेविगेबल वाटर था ही नहीं जैसे यहाँ पे। अगर यहाँ पे दो आइलैंड होते फॉर द एग्जांपल एंड उनकी सेम सिचुएशन होती तो कट दोनों होते और दोनों नेविगेबल वाटर में होते तो हम क्या करते?
Right. Beta, then the question has to give you some extra information to rule out the ambiguity.
Okay.
Some information will be certainly there in the question.
Okay, sir.
Okay?
Okay, sir.
X is the position at 2000 hours, Y is the position at 2045, XY is the CMG, and XY distance is the DMG in 45 minutes. In all these three examples, we had taken a combination of one position circle and one position line. Now let's take the last part of it. At 20.
Okay. Beta, this one is a little complicated. So we have two position circles here. It will be transfer of one and then cutting with the other. Shall I continue? Is it okay?
Sir, yes.
Yes, sir. Continue, sir.
Yes, sir.
Okay, बेटा. Okay. वो कभी-कभी warning आती है ना बेटा when you see social media post, long post ahead. So I thought of giving you a little warning before going ahead. So let's continue.
300 hours, a vessel steering 253 degrees true at 12 knots observes Tusker Rock Light first sighted on its starboard bow.
Video, audio, all okay?
Yes, sir.
At a range of 3.5 miles. At 20:30 hours, Tusker Rock Light was last sighted at a range of 5 miles. If the current during this period was setting south at 4 knots and northwesterly wind caused a leeway of 3 degrees, we need to find position at 2000 hours, position at 2045, course made good, and the speed made good.
Okay, beta. So now you first read the question carefully and let me know if any doubt is there in the question itself. You see, we have a concept of first sighted.
We have a position.
Then we also have a concept of last sighted. The ranges are given here to make the question simpler, but in actual MMD question, they may give you the visibility and the height, so you may need to calculate these ranges. Here the ranges are given straight away for simplicity.
Sir, understood.
Okay, very good. Let's proceed ahead now. You see, we have two position circles, one at 2000 and another one at 2030. Current is there and wind is also there.
Now in this case, we have two position circles. One position circle at 2000 hours where Tusker Rock Light was first sighted. That means it shall be drawn with Tusker Rock Light as the center and first sighting range of 3.5 miles as radius. At 2030, we get another position circle with Tusker Rock Light as the center and the last sighting range of 5 miles as the radius.
Beta, can you check your mic? Somebody's mic is open, looks like.
So if we want to use running fix in this, we can run up the 2000 hour position circle to 2030 and we can get the positions and the required information. Now in this case, since we have to allow for both wind and current, so as we have already know, we first need to allow for wind followed by current. As far as allowance for wind is to be made, it can be made on the answer sheet. So CTS 253 degrees true, you can see the yellow highlighted information. Leeway 3 degrees northwesterly wind.
What is the effective course, beta?
256.
250.
250. 250.
Very good. 250.
So that means the wind is from the starboard side, port side is the lee side or downwind side. So leeway will have to be subtracted. So the effective track or the effective course of the leeway track will be 250 degrees true. So when we have to allow for both wind and current, we allow for wind ideally on answer sheet, and we use the effective course to plot. So now we first draw the 2000 hour position circle. We identify Tusker Rock, this is C1 with C1 as center, and first from sighting range of 3.5 miles acting as radius. We draw this position circle, blue one. This is the position circle at 2000 hours. Now we have to run this circle up by 30 minutes to transfer it to 2030. That means we'll have to transfer the center C1. So we draw the effective course through C1, represented by single arrow. Now ship is doing an engine speed of 12 knots. So in half an hour, the engine distance shall be 6 miles. So we mark of 6 miles on it. We get this point A. Now wind allowed for. Now is the time to allow for current. By now we all know where is the current to be plotted. The current is to be plotted at A. So at point A, we plot the current, and this current is plotted at A southerly, represented by 3 arrows. And since the current set is rate is 4 knots, in half an hour it will be 2 miles of drift, and we do point C. That means C1 to C2 is the course made good, and C1 to C2 is the distance made good in half an hour. In other words, C1 gets transferred to C2. So now with C2 as center and same radius of 3.5 miles as that of 2000 hour EC, we draw the transferred position circle, which is now shown here by the red position circle. This is the transferred position circle for 2030.
Any doubt up to here, beta, in the transfer of the position circle?
No, sir.
Very good.
2030, we have another position circle which can be drawn with Tusker Rock Light as the center and the last sighting range of 5 miles as radius. So we draw that position circle. The green position circle is 2030 position circle, obtained by using the last sighting observation of the Tusker Rock. So now this green position circle is for 2030. The red position circle is transferred circle through 2030. Now where they intersect? Now they intersect at this point out here, and they also intersect at this point. Now these two could be the possible positions of the vessel at 2030 hours.
Okay. So any doubt up to here, beta?
No, sir.
Very good. So we have two options here. So you can see either this could be the position or this could be the position.
Now in this case, we can see that this northerly position is in non-navigable waters, so it gets ruled out. So this one out here is the position of the vessel at 2030. This is 2030 position. Now we draw C1, C2 through this X and equal in magnitude, and where it cuts the 2000 hour position circle, we get point Y, which is 2000 hour position. Additional information given in this question to rule out the possibility was that only at 2000 hours, if this was the position at 2000 hours, then only the Tusker Rock would be on starboard bow. Had this northerly been positioned even in the navigable waters, then its corresponding position at 2000 hours would have Tusker Rock on her port side.
Okay, so did you understand it up to here, beta?
Yes, sir.
Yes, sir.
Yes, sir.
Right. I was telling you that if there are two options of your position, some information will be given to you in the question. So you see this starboard bow which they have given is that particular information. Even if this position, the other one which we ruled out, was in navigable waters, When you draw the CMG backwards and you get your initial position here, you see if you were at that position, the Tusker rock would be on your port bow. So that gets ruled out because of this information, even if it was in navigable waters.
हाँ सर, एक डाउट है सर, अगर क्वेश्चन में अगर हम मतलब प्लॉटिंग में हमें दिखा रहा नहीं, बट आंसर शीट में हमें लिखना है क्या कि मतलब दोनों साइड पे हमने चेक किया और ऐसा करके कुछ?
यस बेटा, यू नीड टू राइट इट डाउन. जैसे इस केस में जो अपर पोजीशन है जो हमने रूल आउट किया है, वी नीड टू राइट ए लाइन इन आवर आंसर शीट that since one of the positions is falling in non-navigable waters, we are picking up the second one as our actual position.
Okay sir, thank you.
Okay.
सर एक डाउट है, हम
बोलो
लोग सर आइडेंटिफाई कैसे करेंगे कि सर कौन सा क्वेश्चन कौन से मेथड से सॉल्व करना है?
बेटा, क्वेश्चन की वर्डिंग जब पढ़ोगे ना आप, व्हेन यू रीड द वर्डिंग ऑफ द क्वेश्चन, मैंने आपको 1 2 3 मेथड बताया था ना एक, when we were doing the basics, I told you about 1 2 3. Understand the question first, then make a rough diagram, and then go for the final plot. You remember?
Yes sir.
Yes sir, remember.
So if you have any doubt any time कि ये जो क्वेश्चन है ये कौन से मेथड से होगा, अभी तो बहुत थोड़े मेथड हमने किए हैं, आगे और बहुत सारे मेथड्स आएंगे. So having doubt in any question which method should be used, first read it carefully, if required twice or thrice, then try to make a rough diagram. Okay, you can make it on your answer sheet. Not that it is mandatory to make it, but it helps you to understand which method will be applied. So जैसे ही आप एक रफ डायग्राम अपनी आंसर शीट पे देखोगे, immediately the mind will capture, it will automatically tell you that this is the method to be used here. अब आपके माइंड को फायर करने के लिए प्रैक्टिस होनी चाहिए. सो दिस इज व्हाट द असाइनमेंट्स आर गोइंग टू डू. असाइनमेंट के जितने क्वेश्चंस हैं वो जब आप प्रैक्टिस करोगे और उनको सॉल्व करोगे, एंड लेटर ऑन यू विल also practice questions from the past papers. So all this practice is going to help your mind in this process. Okay beta? Okay.
सर
बोलो बेटा.
सर ये जो अपना कोर्स मेड गुड आया जो C1 C2 से उसका जो 30 मिनट्स के लिए वो ट्रायंगल है ना, तो स्पीड मिड गुड इज फॉर 30 मिनट्स. तो अगर ये 20-30 जो हमने एक्चुअल पोजीशन है 20-100 to 20-30, तो वो भी सेम होगा हाफ एन आवर मतलब उतना माइल?
ओके बेटा, जो 20 to 20-30 C1 C2 डिस्टेंस आया है, ये हमारा डिस्टेंस मेड गुड है इन 30 मिनट्स. अगर हमें स्पीड मेड गुड निकालनी है तो हमें 1 आवर के लिए हमारा डिस्टेंस, रेस्पेक्टिव डिस्टेंस निकालना होगा बाय इंटरपोलेशन.
नहीं सर वो ठीक है, वो समझ गया मैं, बट ये जो एक्चुअल पोजीशन आई है तो वो डिस्टेंस भी सेम होगा ना?
ओके, यू मीन टू से C1 C2 and XY, these two distances, they will exactly be same beta.
They will be same ना सर?
Yes, they exactly same. बिल्कुल सेम होंगे बेटा.
ओके सर.
ओके, और बताओ बेटा.
नेक्स्ट क्वेश्चन सर.
Done. This is clear.
Yes
sir.
Very good बेटा. So
सर
बोलो.
जो 2045 की पोजीशन आएगी वो तो ईपी पोजीशन होगी ना सर?
Yes, that will be a estimated position. What we will do is we will extend the right 15 मिनट के लिए. हाँ, 15 मिनट के लिए हम इसे एक्सटेंड करेंगे and we will have our estimated position for 2045. Okay, very good. So with this, basically we have covered up the position circle transfer concept. Let me see if anything else is there.
So therefore, This point Y is 2000 hours position circle, X 2030 position circle, XY the CMG, and distance XY the distance made good in half an hour. Double it up to get the speed made good. I hope with these examples, the concept of transfer of position circle is pretty clear to us. And this is where it comes. That means this position is ruled out, which is 180 degrees into 2 miles.
Now another important thing, beta, just look at the diagram and see all the symbols how they are marked. जो भी पोजीशन सर्कल हमने मार्क किया है उसके साथ हमने उसका टाइम भी लिखा है. पोजीशन मार्क की है विद ए सर्कल एंड ए डॉट, उनके साथ भी उनका टाइम लिखा हुआ है. टाइम्स आर मेंशन्ड. सो सीएमजी पे डबल एरोज लगाया है, करंट पे ट्रिपल एरो लगा है, सीटीएस पे या इफेक्टिव कोर्स पे सिंगल एरो लगा है. सो दीज सिंबल्स ऑलवेज रिमेंबर देम टू मार्क ऑन योर प्लॉट. जब आप प्रैक्टिस भी करोगे अपनी चार्ट वर्क की जो बुक है, नोटबुक है, उस पर असाइनमेंट्स प्रैक्टिस करोगे, always ensure that you are using the symbols. So that is another important thing. So with this we cover up the position circle transfer method. So we can take a break now, beta. We have a small method remaining, so we can take a break. What time you want to be back? So next topic जो हमारा है, not a very big topic, it's a smaller one. So that is having a lighthouse or a object at a certain angle on the bow. So let us do this concept. So let me set up the presentation. So give me a minute. So once we do it, beta, so we have our next topic now, having an object at a certain angle on the bow at a given distance without current. So this is a typical kind of question, slightly different from what we have done in earlier questions, because in this question, before we go onto the chart for actual plotting, we have to actually make a rough diagram and do some work before plotting can be done. So in this question, they give us a object, a lighthouse or a certain object, which should be at a certain angle on our bow. The initial position of the ship is given. They want us to steer a particular course. The course is not known, that is what we have to calculate. But the course steered should be such that at a particular distance off, when you are a particular distance off from that object, it should be a certain angle on your bow. To say, for example, they could ask you that find out the course to steer to have, let us say, straight point lighthouse 30 degree on your port bow when it is 12 miles off. So distance off is given to us, that is 12 miles. When we are 12 miles away from that particular lighthouse, it should be 30 degrees on our port bow. So that is the question. Now let's see how do we proceed ahead. First of all, as I told you, the data which is given to us is one, the initial position of the ship is provided. Second, the bow angle at which the object should be is given to us. And third, the distance at which that bow angle should be obtained is also mentioned to us. What we are required to find out is what course should the vessel be steering. Now, before we move on to the chart for plotting, we have to do some rough work on our answer sheet. So let's make a rough diagram. We will try to input all the data or all the information which is given to us in the question in the rough diagram. So let's make a rough diagram here. Let's assume that this is the object which is given to us, a lighthouse. Let's mark it as point A. So we have the object in our rough diagram. Let's mark off our initial position also. The initial position is given in these questions. Let's assume that the vessel was at this particular position. Now, we don't know what course is to be steered. In fact, that is what is required. We are required to find out. So, for the sake of rough diagram, I will be plotting one course here, which should be my CTS. So, I have marked a line on the rough diagram which represents my CTS. I don't know what my CTS is. That's why this is just a rough diagram. Also, I put it in red color, indicating that this is something which we need to find out. Now, let's assume that when we are moving on this particular track, right now this is a hypothetical track. We don't know what our course steer is. So we have just drawn a rough line in whichever direction we like, of our liking. So it's a hypothetical course to steer, but later on we will be able to find out. So let's assume when the ship is moving on this particular course and it reaches at this point Bravo, B point. Now at this particular point, the lighthouse comes at that many degrees on our bow, or in other words, when the ship reaches at point B, the bow angle which we are required to obtain is obtained here, or is materialized or possible here. So let's join the B point with the lighthouse. So Bravo to Alpha is the bearing of this particular light, and this is the bow angle at this particular point, and this is that same bow angle which we were required to obtain. So this is all being assumed now. We don't know where is this point B going to be. We don't know what is the CTS, but we are just assuming and making a rough diagram. Now what I will be doing is, from point A, that is the lighthouse which is the object, I will drop a perpendicular onto my course steered. So from point A, I am dropping a perpendicular onto my course steered. So you can see this perpendicular in blue color. This angle here would be a 90-degree angle. Since it is a perpendicular, the angle would be a right angle. Let's mark this point where the perpendicular touches the CTS as C. So we have this Charlie point here in our rough diagram. Now you see in our rough diagram, there is a triangle, ABC triangle, and this ABC triangle is a right angled triangle. Angle C is the right angle. Now side AC is the perpendicular, considering angle Bravo, the bow angle. If I consider the bow angle, then this side AC is my perpendicular, and the side AB, Alpha Bravo, which is basically the distance from the lighthouse when it is at a certain bow angle, is the hypotenuse. So you see, opposite to the right angle, side AB is the hypotenuse and side AC, alpha Charlie, is the perpendicular. Now we know in a right angle triangle, sine of any angle or sine theta is equal to perpendicular upon hypotenuse. So in this particular case, triangle ABC, we have the sine of bow angle equal to perpendicular, which is AC alpha Charlie, divided by hypotenuse, which is AP alpha Bravo. So let's note this down. You can see this here. The sine of bow angle is equal to perpendicular, which is AC, upon hypotenuse, which is AB. Now, if you look carefully in the diagram, this side AC alpha Charlie, a perpendicular from the object to our course steered, is basically the beam distance of the lighthouse. You can also say it is the nearest distance of the lighthouse. In these questions, as you see, it is specifically mentioned that there is no current which is given. These questions are given to us without any current. So since there is no current, our CTS and CMG is going to be same. So this alpha Charlie, the perpendicular from the object to our CTS, will be the beam distance of this particular lighthouse, and it will also be the nearest distance when you are moving along your track. So AC is our beam distance and AB is the range of the lighthouse, or the distance from the lighthouse when it is at that particular bow angle. Now you see in the data which is given to us, the bow angle is already known. So that's why you see the bow angle is marked in green. The range of the lighthouse, or the distance of when that particular bow angle is attained, is also known to us. So AB is also marked in green. The only unknown in this equation is alpha Charlie, which is our beam distance or the nearest distance. So if we put these two values here, that is the value of the bow angle and the value of the distance of or range, which is alpha Bravo, both given to us in the question, we should be able to easily calculate our beam distance or nearest distance alpha Charlie. So using this, using sine of bow angle equal to beam distance upon range, we find out the distance AC, the beam distance or the nearest distance of the object when we are moving along our track. You can note down this formula, you can memorize it, and in case you are running short of time in the question paper and you are not able to make this rough diagram, then in that case you can straight away use this formula and find out the beam distance or the nearest distance and use it in your plot. However, if time is there, it is recommended that you make a small rough diagram like this so that the examiner knows from where you have obtained the formula.
सर
हाँ बोलो बेटा।
सर इस केस में जैसे आपने बोला कि ए बी हमें पता है, बट सर हमें वो भी एक्चुअली तो नहीं पता है क्योंकि बी तो हमने अज्यूम किया है पोजीशन, राइट?
बेटा see on the left side on the data given, they will tell
इनिशियल
you
पोजीशन पता है सर हमें। at given distance भी पता है सर?
Right, they will give us the bow angle and they will give us the distance also कि इतने distance पे ये bow angle होना चाहिए. So this will be given to us, beta. Okay, you can have a screenshot, beta. You can click a screenshot and save it with you. So this takes care of this kind of question. Any more doubts coming till now?
No, sir.
Okay. So let's see its plotting now on the chart. This was a rough diagram. Once you know the beam distance or the nearest distance, now we can easily solve this question. It can be plotted on the chart and the CTS can be found. So let's move on to the chart. Now once the beam distance or nearest distance is known, then we can go on to our chart and start the plotting. So let's move on. Let's open up the chart of the area. So we have the chart on our screen now. The object which is given to us in this particular question is the straight point lighthouse. You can see this lighthouse here. I have highlighted it. So we need to keep this straight point lighthouse at a certain angle on our bow. The initial position is also given to us in these questions. Let's mark off the lighthouse as point A on the chart. Now let's plot the initial position which is given to us. So you can see the initial position here in this particular location at deep sea pilot point. So this is our initial position. We need to find a particular course which we should be steering so that this straight point lighthouse is at a certain bow angle when it is at a given range or given distance off. Now you see in our rough diagram, we have already found out what will be the beam distance or the nearest distance of this particular lighthouse when we are moving on our planned CTS. So what we are going to do now is we will draw a circle centered at our reference object, which is this lighthouse, the straight point lighthouse, and whose radius is equal to the beam distance or the nearest distance from this lighthouse when we are moving on our track. Okay, so drawing a circle centered at our object, that is the straight point lighthouse, with radius equal to the beam distance or nearest distance on the chart now. So you can see the circle on the chart. Ask again, beta.
So do we need to draw a circle full or half or just an arc of it will be okay?
You can draw it only in the navigable waters, beta. If you want, you can draw it only in the navigable waters. Even if you want to draw full, both ways it is okay.
No, sir. If less than even semicircle, like small arc or little.
That's
arc.
okay, beta. That also can be done. That also can be done. We only need a small part of the circle. So if you want, you can draw a small arc also.
सर ये तो ड्रॉ कर रहे हैं सर, इसका क्वेश्चन ओपन करेंगे क्या? क्वेश्चन इसका कोई जिसमें वैल्यूज दी हो?
Say again, beta.
सर ये जो भी हम लोग कर रहे हैं सॉल्व कर रहे हैं सर इसका क्वेश्चन किधर है? क्वेश्चन रहेगा क्या?
नहीं बेटा, मैंने यहाँ पे कोई क्वेश्चन नहीं रखा है. आई हैव जस्ट टेकन ए हाइपोथेटिकल सिचुएशन. आई हैव टोल्ड यू कि क्या इंफॉर्मेशन हमारे पास अवेलेबल है और कैसे हमने इसे करना है. सो ओनली द प्रोसीजर इज बीइंग गिवन टू यू. आई हैव नॉट टेकन ए क्वेश्चन.
ओके सर.
तो सर इसमें तो बेसिकली ये हो गया ना कि कोई भी सर्कल से कोई भी जो लाइन पास होगी, टेंजेंट पास होगी, वो 90 डिग्री होगी, उसकी वजह से दैट विल बी द कोर्स गोइंग ऑन ऑफ दिस.
राइट बेटा, दैट्स राइट, दैट्स राइट. Okay, so shall we proceed ahead now?
Yes.
Okay, so from our initial position now, moving further, I am going to draw a tangent to this circle. So from the initial position, which is plotted on the chart, I am drawing a tangent onto this circle, whose radius is the beam distance or the nearest distance. Let's plot it. So you can see this line from my initial position, tangent to the beam distance or nearest distance circle. Now this line which we see on our chart now is our course to steer. This is the course to steer. Now the point where this tangent touches the circle, the tangential point, let's name that point as C, Charlie point. We know the radius of this circle, which is shown by this dotted line alpha Charlie, is equal to my beam distance or nearest distance, and you see this is also perpendicular to my course steered line. A tangent is perpendicular to the radius of a circle, so angle C here becomes a right angle. Now we can align our parallel ruler to the course steered line, transfer it to a compass rose, and you can read off what course do you need to steer to have this lighthouse at a certain angle on the bow at the given distance. Now once the CTS is known, we have the bow angle known to us. So by adding or subtracting the bow angle to our CTS, depending upon whether the lighthouse is on our starboard side or the lighthouse is on our port side. If it is on the starboard side, the bow angle will be added to the course steered. If the object or lighthouse is on the port side, the bow angle will be subtracted from the CTS. Now when we do this, we will obtain the bearing of that particular object. So find the bearing of the object at the required bow angle by either adding or subtracting the bow angle to the course steered. So we will obtain the bearing of the straight point lighthouse. In this case, once the bearing is obtained, we draw that bearing line passing from the lighthouse. So let's plot it on the chart. You can see this bearing line plotted on the chart now. Now the point which meets our CTS. बोलो बेटा.
सर वो सीटीएस कैलकुलेट करने के बाद नहीं समझ आया. आपने कहा सीटीएस पैरेलल है तो सीटीएस से कर लो, आपका सीटीएस आ जाएगा. उससे आपको प्लस माइनस 90 करके आपको परपेंडिकुलर वो वहां से सर मिस आउट हो गया.
ओके बेटा, नो प्रॉब्लम. लेट अस अज्यूम कि इस क्वेश्चन में हमारा जो सीटीएस है इट कम्स आउट टू 040, राइट? लेट्स टेक एग्जांपल. नाउ जो bow angle उन्होंने हमें क्वेश्चन में दिया है, let's say they have given a bow angle of 30 degrees. So if you are steering 040, there is a object which is 30 degree on your port bow. Can you tell me what will be the bearing of that object?
10.
That will
Yes,
be
sir.
010. So this is what I said, beta.
ओके सर।
Is it clear now, beta?
सर ये एंगल माइनस करने की उससे अच्छा है वो डिस्टेंस दिया ना, उतना कंपास से लेके ए पॉइंट से कट कर सकते हैं लाइन पे, सीटीएस पे, तो सेम वो भी
I'll
लाइन आ
come
जाएगा।
to that. That also can be done, beta. I'll just come to it.
ओके ओके
Okay. Let's name that point as Bravo. So you see point Bravo here on the chart. It is at this particular point that the lighthouse will be at the required bow angle and it will be at the required distance off. Both the conditions would be satisfied. Now, if you measure this bow angle here, which is being made, this is the angle between the CTS and the bearing of this lighthouse. So this is the bow angle here. If you measure it, you will find that this is exactly the same bow angle which was mentioned in the question. And secondly, if you measure this distance AB, you will find that automatically this AB distance will be equal to the distance of which we were required to maintain as per the question. So this will be the same distance what was given to us in the question. So now you can see this is the same ABC right angled triangle. Angle B is the bow angle. Alpha Charlie AC, the dotted line, is the perpendicular which represents the beam distance or the nearest distance, and Alpha to Bravo, the green color line, is the distance off from the lighthouse which represents the hypotenuse of this particular triangle. Now there is one more way with which you can find out the position of point B. That is, instead of plotting this bearing line, what you can do is, after you have plotted the CTS here on the chart, you can mark an arc which is centered at the lighthouse and having a radius equal to the distance off. So what you do is you open up your compass equal to the distance off which is given to us in the question, which we need to maintain from the required lighthouse. So open it up equal to the distance off, center the compass at the lighthouse, straight point lighthouse, and then draw an arc so that it cuts our CTS line. So when you draw that arc, you will see that that arc is going to cut the CTS exactly at point B. So once the arc cuts the CTS, you obtain this point B. Now you can draw a line joining Alpha to Bravo. So that gives us the bearing line of the lighthouse. So if you do that way, then this angle, if you measure this angle after completing the triangle, you will see that automatically the bow angle will be maintained. Whatever bow angle was required, the same bow angle will be maintained here. So initially we had to calculate the beam distance or the nearest distance from the rough diagram. Once it is calculated, the plot can be made on the chart. And you can now appreciate that it is not possible to do the plotting straight away with the given information. So first find out the beam distance or the nearest distance of, and once known, draw the circle, the nearest distance or beam distance circle, and from your initial position draw a tangent line, and then you can draw either the bearing of that particular lighthouse using the bow angle, or you can mark off an arc of equal to the distance off from that lighthouse to obtain point B, where this condition will be satisfied. So this completes our topic, having an object at a certain angle on the bow at a given distance without current. Okay, so beta, any doubt in the mind related to this one?
No, sir.
Lot of work completed today, lot of concepts understood, so that was a great session. So try to revise these concepts what we have done today, and what I'll be doing is I will be sending you the second assignment now. So I'll send it by today evening, so you can start to attempt this assignment number 2. So I have a session with you tomorrow also, beta? No, I don't have it tomorrow.
No, sir.
No.
Okay, all right. So you have the full weekend available to you. You can practice assignment number 2. So that's all for this session. See you in the next session then.